So here we see the action potential, and what you might need to be able to do is to interpret a graph like this in terms of what's happening at the cell surface. So at point 1 and 2 you should be able to see or interpret from the graph that it's at the resting potential of negative 60 millivolts. Now at between points 2 and 3 what's happening is the action potential has arrived, and this causes sodium channels to open. The sodium channels open here, and that depolarizes the membrane. So for about 1 millisecond the membrane will reach about positive 40 millivolts. Now here the sodium channels close and the potassium channels open. Now with the potassium channels open, potassium will move out of the cell and cause it to become repolarized. Now at 8 it's repolarized, but it's polarized a little bit more than it normally is, so it will probably reach about negative 75 millivolts, and this is called hyperpolarization. At this point it can still open its sodium channels, but it would need a greater action potential to reach the threshold. I'll cover threshold potentials in more detail in a later video. At point 9 here, between point 8 and 9, we see it has returned to its resting potential of negative 60 millivolts as the potassium-sodium pump kicks back in. So 3 sodium are again pumped out for every 2 potassium that are pumped back in, and then that is ready for the next action potential.